Okay, we're going to do an introduction today to transformations. But before we do that, really quickly, what did you guys find your answers to be in this rewind? The same for the first two were 26, square root of 26, which means that that's approximately a little bit bigger than what?
25.
A little bit bigger than 25. What's the square root of 25? She's right. Yeah, the square root of 25 is 5. So this would be a little bit bigger than 5. All right, so like 5.1 or something like that. And then this one is 32. What perfect square is that closest to? 36. Is it bigger or smaller than that? Smaller. So this one would be a little bit smaller than 6, right? So it might be like 5.7 or 5.8, something like that. So they're really close. These two are exact. Does anybody know what a triangle is called when two of the sides are the same? You don't need to know this yet, but it starts with an I. Martin? Yeah, isosceles. Good. So isosceles triangles have two of the same sides. So we'll start talking about that in chapter 3. All right. Okay, good job on that. So transformations, like I said to Micah when you guys came in, this is going to be a pretty brief lesson. There's not that much to it, and it's relatively simple because we're not getting too into the complicated actual transformations that are happening. We're just identifying them. We'll do more of this at the end of the year. In chapter 12, we'll do like an in-depth view of transformations. But today, all we're really talking about is 3 basic types of transformations and how to recognize them. So a transformation is just a change in the position, size, or shape of the figure. And the 3 that we're talking about today are only changing the position. So we're not changing the size and the shape today. We're just talking about changing position. And there's 3 ways that you can do that. What does position mean, though? What is position? If I say, like, the position of my body is standing right now. What? Okay. It's like how I am, right? Position is like where something is or how it is. Like the position of Cristo Rey Jesuit is right next to Our Lady of Mount Carmel. Okay, so position is just where something is or how it is. And what we're going to talk about today is how you can change those. And so there's 3 ways that we're talking about: reflection, rotation, and translation. And all 3 of these are things that you probably already know. What is a reflection? The same image, but what's happened to it? It's flipped, exactly. So there's like the reflection is, it's not like a fancy word, but it's the more technical term for what we would just refer to as a flip. All right, so a reflection is just a flip. And it's across a line. So that means this line right here, we went from B over here to B prime. And that was the flip that happened. So we went from the blue figure to the red figure by flipping it across that line. So this one flipped across a vertical line. If it had flipped across a horizontal line, where would this be now? Yeah, this would be on top and that one would be underneath it, okay? And the way we denote the new figure, this is called the pre-image because it's the one you started with. And this is called the image. And you know that it's the image because it's got these little apostrophes here. So we call that ABC in the original pre-image, and then A prime, B prime, and C prime in the new image. Why do you think we use A prime, B prime, and C prime rather than like D, E, F? Micah? It's the same image. So we haven't changed the image. It's the exact same figure. We're just manipulating the movement. So I want you to know that A here goes with what over here? A prime, exactly. So I want to use the same letter, but I can't just call it ABC because something happened to it, right? So it changed a little bit, and we indicate that by using these apostrophes, and you will hear it as A prime, B prime, and C prime. So again, here's our pre-image. And what does the prefix pre mean? Before. And then here's our image. So we've got our image and our pre-image. Our pre-image just happened before. And in this case, it was a reflection because it was flipped. Yeah. After it's already been flipped. Yep. And you might see double prime, which would be if 2 transformations happened. So single prime would be one thing happened. Double prime would be, say you like reflected it and then rotated it. You'll have a pre-image, a prime, and then a double prime. And double prime just indicates that two movements have happened. And that would look just like A, B, C with like quotation marks almost. All right, so if a reflection is a flip, what's a rotation? Yeah, you just turned it. All right, so you just turned it. And here the key is, did you turn clockwise or counterclockwise? So what do those words mean? What is clockwise or counterclockwise? One goes to the right, one goes to the left. Which way is clockwise? Which way is counter? Clockwise is to the right. Counter is to the left. Why do we use the word clockwise and counterclockwise? It's like how the clock turns, right? So clockwise would be to the right, counterclockwise would be to the left. So this one, which is our pre-image? The blue one. And then our image is the red one. And you know that because it's got the primes. So that's our new image. So then did that turn clockwise or counterclockwise? Counterclockwise, exactly. That's all you guys are going to need to identify for me at this point. Did it go counter or did it go clockwise? All right. Later when we do this, we'll figure out how many degrees it turned. But right now we're not worried about that. Okay? So just clockwise or counter. And again, clockwise to the right, counter to the left. All right, so let's identify the transformations that happened here. Oh, wait, we have one more. Sorry. The last one is a translation. And a translation, if we call a reflection is a flip, a rotation is a turn, a translation is just a slide. So literally all that happens with a translation is you're moving it one way. You're not flipping it, you're not rotating it, you're not turning it at all, you're just moving it in one way. And the easiest way to tell if something is a transformation is if the J is in the top left here and the J is still in the top left here, it's a translation because none of the vertices change position at all. They're just shifted, okay? So it's got the same exact shape. It's not turned, it's not rotated, it's not flipped. It's just in the exact same positioning but shifted, moved across the page, all right? And a translation is going to happen on a coordinate plane more often than not. And with a translation, what you're going to have to identify is how far it moved, okay? So you would say like it moved 2 to the right and 3 up or whatever. And we'll look at an example in a minute. Okay, so is a reflection, a rotation, or a translation? It's a reflection. How do you know that? Urath? Okay.
It like kind of mirrored it, but like
Yeah. Yeah, it's G was where in the blue one? On the right side, right? And now G is on the, so it would have had to flip. Okay? So this would be a reflection. Did it reflect across a vertical or a horizontal line? Vertical. It reflected across a line that would be like right here. All right, what about B? B looks like a rotation. B looks like a rotation because T was on the right, on the top right, and now it's on the top left, so it looks like it turned. Which way did it turn? Counterclockwise. How do you know which one is the original image, the pre-image? Doesn't have the apostrophes, good. So you know it went from blue to red, so that means it turned left, so that's counterclockwise rotation. Okay, so how do we do this if I just give you coordinates on a coordinate plane? So this long paragraph up at the top says a figure has vertices at A, B, and C, After a transformation, the image of the figure has vertices at A prime, B prime, and C prime. Draw the pre-image and image, and then identify the transformation. So how would you approach doing this problem? Plot it, and then plot the new one and see what happened, right? So before I start, does anyone have guesses on what this figure is? How do you know it's a triangle?
It
Only has three vertices, so it can't be a square because then it would have four, or a rectangle. Can't be a parallelogram, parallelogram would also have four. Couldn't be something like a pentagon because then it would have five. All right, so I'm going to do the first one in blue. So A is -1, +4. B is -1, +1. And C is 3, +1. So not only is this a triangle, but what kind of triangle is it? It's a right triangle. Good. It's a right triangle because this is a vertical line and this is a horizontal line. All right, so then that's my pre-image. In my image, A prime is at -1, -4. That's A prime. B prime is at -1, -1. And C prime is at 3, -1. So looking at that, what would you say that it is? It's a reflection. Is it a reflection over a vertical or a horizontal line? Horizontal, good. Because this line is basically the line through the middle. So not only is it a horizontal line, which line is this? What do we call this line here? The x-axis. So we would say this is a reflection over the x. And you'll notice, how far is the blue one from the x-axis? How many spaces? 1. And how far is the red one? 1. Do they have to be the same for it to be a reflection? Yes, because if you're flipping it, you have to be the same distance from the line that you're flipping it from. Again, we're not going to worry about that too much till chapter 12. All you really need to know here is reflection. All right, so reflection is like a flip, rotation is like a turn, translation is just like a shift or a slide. Okay, so at your boards, try these three. The first two are just naming them, and then number 10 is doing what we just did. If you guys would, nope, you can do it. Draw a coordinate plane to the board. Okay, so with number 10, the easiest way to recognize that it is a translation is how? How does it, because at first, if you first look at it, because it's a square, it kind of looked like it could be a rotation. So how do you know that it's a translation and not a rotation? Ash?
Like J and K, they were still both at the top.
Exactly. So what do you have to do when you put these on a coordinate plane?
You have to like mark it exactly.
Yeah.
Like you have to still label it.
Yeah, you have to label your points because otherwise, especially with a square, if it looks exactly the same, a rotation and a translation are going to look identical with a square. With a triangle, it's different because the shape of it actually, like the position of it actually changes. But since a square is all equal sides, it might look the same. So the only way you would know is if you label your points. And again, why do these have these little apostrophes? That's the new image, right? So the pre-image has no primes, primes meaning these little apostrophes. The new image has those primes. And again, we use the same letters because you want to be able to tell that J and J are in the same spot on the square. Okay, with translations, the other way you can do them is to be given what's we sort of will call it a vector. But what a vector means is basically just direction and movement. So what's happening here is we've got our original coordinates, x, y. And this right here is essentially just the directions that tell you how much it moved. Okay, so each x coordinate is going to move how much? 3 which way? To the right. And then each y coordinate is going to move down 4. So all the x's will move 3 to the right. All the y's will move down 4. So when I have here's my pre-image in blue, so I'm going to do my new image in red, and when I do that, I take A, B, and C, and I add 3. So what's the coordinate of A right now? -1, 1. What's the coordinate of B? -3, 3. And then what's C? negative 4, 0. Good. Okay, so again, you've got a couple options. You can either count it or you can do the addition and subtraction. The only reason you want to do the addition and subtraction is because they're not always going to give you a coordinate plane, and if you don't want to have to draw one, you can do it mathematically. But let's do one by counting and then one by actually applying it. So A, I want to move how many to the right? 1, 2, 3, and then I want to move 1, 2, 3, 4 down. So this is A prime now. All right, so that's A prime. B, if I add 3 to my x, what does that give me? 0, so my B prime would be 0. And then if I subtract 4 from the y, what does that give me? 3 minus 4, negative 1. So B is at 0, negative 1, which is right here. Here's B prime. And then C prime, and again, whatever way you think is easier. In this case, counting is probably easier because you have the coordinate plane. So we would go over 3 and then down 4. And here's C prime. So here's my new image. All right, so it translated to the right and down. If I don't give you that coordinate plane, doing the math is just fine. You add 3 to the x and you minus 4 from all of your y's. Before you do that, you have to have the coordinates, obviously. Okay, so whatever way is easier for you, it doesn't really matter. It just kind of depends on if you want to draw a coordinate plane or not. All right, so let's say that I gave you this. All right, if this were my translation, and I'm going from DEF to D prime, E prime, and F prime, this is the direction. Which way is this moving? If you were just describing to me which way this is moving, which way would this be moving? Is it moving to the left or right? Left. How do you know that? Next to the x. So the x tells you left and right, whereas the y tells you up or down. So it's moving 4 to the left and then up 2. Good. So I take D, and what do I do with the 5? Subtract 4, which would be 1. And what would I do with the 4? Plus 2, which is good. Okay. What about E? Subtract 4, which would be negative 7, and then add 2, which would be 0. All right, and then last but not least, F would be what? 2, comma, positive 1. Very good. Because you subtract 4 from the x, and you add 2 to the y. All right, so if you don't have to draw it, if they just ask you for the coordinates, it's probably faster just to do the actual math. Okay? Again, remember, this only applies to which letter? X, so it only goes with the first term of your coordinate, and this only applies to y, so that goes with the second term of your coordinate. All right, so you're just doing plus 2 and minus 4, but you just have to be careful which one you're doing it to. So this is your new image right here. Do you have to plot it? Not unless it tells you to. Okay? Most of the time on a test or a quiz, I'm just checking for the coordinates. If a coordinate plane plotting it helps you do that, by all means do it, and usually I'll give you a blank one so that you can do it if you want to. But if it's just as easy for you to do it mathematically, just do it mathematically. All right, that's typically going to be an option. Okay, so at your boards, find the coordinates for the image of RST. If RST went from here, and these are your directions, okay? X minus 2 and X minus 8. So you just need the coordinates. If you want to plot it, you can. You don't have to.